All right, so in the last section of notes, we talked through how this pattern is starting to form. It's kind of decreasing by 1, 6 zeros, 5 extrema, 4 points of inflection. So we're going to kind of come to talk about how that pattern kind of fits in with these three different items that we're going to be finding. The zeros, we're going to say that the number of zeros in a polynomial, the maximum number of zeros, is equal to the degree. And remember that your degree is your highest exponent. So in that last example, the degree would likely have been 6, since that's the maximum number of zeros. It's going to correspond there. Extrema, at most, a polynomial will have extrema equal to a degree minus 1. So like in that last example, it was 6 and then 5, degree minus 1 from there. Then points of inflection, a polynomial will have at most points of inflection equal to the degree minus 2. So for example, if some polynomial had a degree of, say, 12, then it would have at most 12 zeros, at most 11 extrema, and at most 10 points of inflection, the degree minus 2. Now these are maximum numbers, meaning that they could have fewer, but it's going to kind of work with this pattern because if you think about it, for every extrema, you could have a point of inflection in between those, but you're going to have fewer points of inflection than you are extrema. And for your zeros, when you have an extrema, that's where it creates the possibility that you could have 2 zeros on either side of that extrema. And then that 0 could be on either side with the next extrema and so forth. All right, so to kind of summarize there, if the degree is n, the polynomial will have at most n zeros, so it'll correspond, n minus 1 extrema, and n minus 2 points of inflection. But again, these are maximums. They could have fewer. Okay, so in these two examples, we're taking the equation and we're kind of trying to find all of this information here. So first of all, the degree is going to be the highest exponent. Here it's 4. The leading coefficient is going to be the coefficient in front of that term, and so that'll be 3. The constant is going to be at the end, -5. And then the end behavior. Remember, the end behavior relies on whether the degree is odd or even and whether the leading coefficient is positive or negative. Here, the degree is even and the leading coefficient is positive. So if I consult back to this page, let's see, I've got an even positive. That's going to be up, end behavior. Okay, so my maximum number of zeros corresponds to the degree, so that's going to be 4. My maximum number of extrema is going to be 1 less, so that's going to be 3. And then my maximum points of inflection are 2 less than this or 1 less than this, so that's going to be 2. And if we kind of try and visualize this, if it's got up, end behavior, if it's got 3 extrema, that would mean it kind of does 3 hills and valleys, that kind of thing. And that would mean you'd have a point of inflection in here and a point of inflection in there. At the most, that's going to be your corresponding to your 2 points of inflection. And then your zeros are going to depend on where your x-axis crosses. If it crosses through here, that would definitely give you 4 zeros. But if your x-axis crosses through here and only hits at that one spot, it would miss this extrema and you wouldn't have any zeros on that side. Or potentially, the curve could be totally above the x-axis and you might have no zeros. So that's how you can kind of see some of the variations, why we say this is the maximum number of any of those categories. All right, let's try the next one. Here the degree is 3. Leading coefficient is -1. Constant is 3. Forgive me. End behavior there is, let's see, it's going to be an odd negative. So odd negative, if I consult back here, is going to be up, down. Maximum number of zeros corresponds to the degree. Maximum number of extrema is going to be 1 less than that. And maximum number of points of inflection is going to be 1 less than that or 2 less than that. All right, so that could potentially look like, let's see, we're going up then down. So maximum number of extrema would be 2. So it's going to have 2 hills and valleys like that, extrema there. And then depending on whether your x-axis crosses there, it could have 3. It could cross down below and have none. It could cross, actually that would have 3 as well. But just depending on where it crosses, you could have some of those variations there. All right, last question. Can you determine the degree of the polynomial graphed on the previous page? Well, I already kind of gave you a hint as we were going through. So if this has this pattern of 6, 5, 4, it would have to have at least a degree of 6. It could be higher, but more than likely it's got a degree of 6 that corresponds with a even function since it's going up, up. So more than likely it's got a degree of 6. All right.